right, today we're going to do some applications of the matrices, and these are actually really pretty cool. So this is hopefully going to be a really fun lesson. The first example we're going to look at is a food web. So we have here that a cat will eat a rat and it will eat a mouse. And then a rat will also eat a mouse. And what the food web does is it's going to take a numerical representation of each animal. And we're going to do a couple of things with it. The first thing we're going to do is we're going to do a direct food source. So we're going to make a matrix using ones and zeros. A 1 will indicate that that animal ate the other animal. And a 0 means that the animal does not eat that one. So we're going to call this matrix F for food web. Okay, just to give it some context. And we are going to have the labels for the rows be 1 for cat, 2 for rat, and 3 for mouse. So that is the creature itself. And then the names of the columns is going to match. This, though, is the cat is eaten, the rat is eaten, and the mouse is eaten. So let's go back to our ones and zeros. So our first column, first row, does the cat eat a cat? Not according to this diagram. So that's going to be a 0. Does the cat eat a rat? Yes. So that's a 1 because that's a yes, it eats it. Does the cat eat a mouse? Yes. So that's a 1. So now we go to our second row. We are thinking about the rat. Does the rat eat a cat? No. Does the rat eat a rat? According to this web, no. Does the rat eat a mouse? Yes. And then we have the mouse. Does the mouse eat the cat? No. Does the mouse eat the rat? No. Does the mouse eat another mouse? No. So right there's the direct food source. Okay. Now the indirect food source, which once we calculate it, we'll talk about what it means. It's actually pretty interesting. You are going to find that by F squared. So use your graphing calculator, program in your 3x3, and I want you to square it, and you will find the following results. It's a lot of zeros. Now keep in mind, this is still the same representations as in the original matrix. And so let's talk about what this means. We only have the 1, 1 on the inside, and that is that cat eats mouse. So what this means is the cat indirectly, so this isn't meaning the cat eats a mouse. That is direct, right? The cat can eat a mouse, but the cat can indirectly eat a mouse if the rat ate a mouse and then the cat ate that rat. So indirectly, the cat is eating the mouse. It can also directly eat the mouse, but it can also indirectly eat the mouse if it eats the rat that ate the mouse. So it's like one of those trickle effect kind of deals. Okay, so that's how a food web works with matrices. They're very interesting. In your homework, we'll get into some more diving questions on like what all these numbers mean, but follow your homework and it'll lead you through it very nicely. All right, now we get into encryption, and these are really fun. When you're working with an encryption, essentially you have a key matrix times a secret message matrix times it's going to give you the encrypted message. So it's like a coding. So if you are wanting to find just the secret message, remember you've got to undo the key. So you need to multiply both sides by the inverse of the key. But remember that that has to come first. That says key. When you are multiplying. So you have to take the inverse of the key times the encrypted message in order to get the secret message. So to make that happen, we're going to say that up here is the general code, and it's the English alphabet, but 0 is a space. We are going to have this be our key, and we want to code the message Highland. So how do we do that? Well, I have to take matrix M times another matrix, and then that's going to create the encrypted. But let's talk about, this is matrix multiplication, so we've really got to work on our dimensions. Matrix M was a 2 by 2. So in order to multiply these, this second matrix has to have 2 rows. But I'm not quite sure how many columns. Well, look at how many letters are in the word Highland. There are 8. So I just need 8 elements. So I'm going to make this a 2 by 4. So let's bring some numbers in here. So here's my key. And I'm going to create my secret message of Highland. So for the letter H, that's an 8. So I'm going to go 8. And then an I is a 9. G is 7. H again is 8. Now I'm just going to move to my next row. L is 12. A is 1. N is 14. And D is 4. And then I'm going to use my graphing calculator. You can absolutely multiply these out by hand if you wish, but you can also use a graphing calculator, which I think is a little faster, but you do it however you want to. But when you multiply those two matrices together, you get the following encryption. So this right here is our encrypted message. Notice there's negatives, right? Well, if I look up at the English alphabet, none of those are negatives. So with the legend that I have, I wouldn't know what this message is without my key. Okay, now let's reverse the process. What if I use the same key or the same legend? I have this is my key and this is my secret message, and I need to decode it. Well, to find my encrypted message, remember I had to multiply both sides, or not my encrypted, wrong one. If I want to find my secret message, I need to take the inverse of my key and take it times the encrypted. So again, I would use a graphing calculator. I would take M inverse times A. And when I do that, I would get the following code. And now I'm going to use my legend up above to see what this has. So 25 is a Y, 15 is an O, 21 is a U, 0 is a space. That's looking promising. It's at least a word, right? 3 is C, 1 is A, 14 is N, and then another space. 4 is D, 15 is O, and then another space. 20 is T, 8 is H, 9 is I, and 19 is this, or S. For your secret message is you can do this. And that's encryption using matrices. So have fun with your homework. It's always super interesting, and see what you come up with.